Hello to all our wonderful listeners. Welcome back to another episode of Special English Corner. I am your host, Mark. Today, I am feeling very excited because we are standing in a place where dreams touch the stars.
And I'm Sharon. Hello, everyone. Mark, I can see the excitement in your eyes. We are currently at the Harbin Institute of Technology, or HIT, inside the famous Astronautics Museum.
You know, Sharon, people call HIT the cradle of Chinese astronautics. For our beginners, a cradle is a small bed for a baby. It means this is the place where the Chinese space program was born and grew up.
That is a perfect explanation. This museum is a treasure house. It is filled with real rockets, satellites, and spacecraft that have actually been to the vacuum of space.
Vacuum. V-A-C-C-U-M. That's a big word for our listeners. It means a place where there is no air. Space is a vacuum, and the machines we see today were designed to survive in that empty, silent world.
In today's very special, extra-long episode, we are going to walk through this museum together. We have divided our journey into 4 big parts.
Part 1. The Giants of the Hall. We will talk about the massive Long March rockets. Part 2. Small but mighty. We will explore the satellites, especially the ones made by HIT students. Part 3. The Human Adventure. We will look at the Shenzhou spacecraft and how astronauts live in space. Part 4. To the Moon and Beyond. We will discuss lunar rovers and the future of Mars exploration.
It is going to be a long walk, so make sure you are comfortable. Let's begin our journey through the stars.
Part 1. The Giants of the Hall. Rockets and Launch Vehicles. Wow, Sharon, look up. I feel like an ant standing next to a giant tree. But this tree is made of silver metal and reaches all the way to the ceiling.
You aren't exaggerating, Mark. We are standing next to a model of the Long March rocket. In English, we call these launch vehicles. A vehicle is something that carries you, like a car or a bus, but a rocket is a bus that goes to space.
Let's look at the name Long March. In Chinese, it is Chengzheng. This name is very important in Chinese history. It represents bravery and never giving up.
For our beginners, a march is a long, steady walk. To get to space, you need a long, steady push. These rockets provide that push.
Look at the bottom of the rocket. Do you see those big bells? Those are the engines. E-N-G-I-N-E-S. The engines burn fuel to create thrust.
Thrust, T-H-R-U-S-T. That is the force that pushes the rocket up. Mark, why does the rocket need so much force? Why can't we just fly a normal airplane to space?
That is a great question, Sharon. It's because of gravity. Gravity is the invisible hand of the Earth that pulls everything down. To leave the Earth, a rocket must go very, very fast. It needs to reach about 7.9 kilometers per second.
7.9 kilometers in 1 second? That is faster than a bullet.
Yes, and because space is so far away, the rocket is built in stages. If you look closely at the rocket in the museum, you can see lines where it can be separated.
Stages, S-T-A-G-E-S. For our listeners, think of a rocket like a series of smaller rockets stacked on top of each other. When the first part runs out of fuel, it falls away. This makes the rocket lighter so it can go faster.
Exactly. It's like taking off your heavy backpack when it's empty so you can run faster. HIT has played a huge role in developing these stages, especially the Long March 5, which people call the Fat 5 because it is so wide and powerful.
I love that name, Fat 5. It sounds friendly, but it is actually a beast. It can carry 25 tons into space. Mark, 25 tons is like carrying 5 large elephants.
Imagine 5 elephants flying into the sky. That is a big success. But the rocket is just the delivery truck. It is not the most important part. The most important part is the package at the very top.
Right, we call that the payload, P-A-Y-L-O-A-D. The payload can be a satellite, a telescope, or even a house for astronauts.
In this hall, we can also see the fuel tanks. They are huge. Most of a rocket is just a giant tank of juice to help it move. It reminds me of how hard it is to reach the stars. You need 90% fuel and only 10% spacecraft.
It shows us that big dreams require a lot of energy. Just like learning English, you need a lot of fuel, which is your practice, to reach the space of being a good speaker.
What a beautiful metaphor, Sharon. Practice is the fuel and your voice is the rocket. Now we are moving into the second part of the museum. This area is filled with objects that look like golden boxes with blue wings.
These are satellites, satellites. A satellite is something that orbits or circles the Earth.
Mark, why do they have those blue wings? Are they for flying like a bird?
No, Mark. There is no air in space, so wings for flying don't work. Those blue wings are solar panels. They catch sunlight and turn it into electricity.
Ah, so the sun is their battery. That is very smart. We have many types of satellites here. Some are for the weather, some are for GPS maps on our phones, and some are for taking pictures of the stars.
But the most special satellites in this museum are the lilac satellites. Lilac is a flower, the city flower of Harbin. These satellites are very small. Some are only the size of a shoebox.
A shoebox? Can something that small really work in space?
Yes, these are called nanosatellites. And here's the coolest part. The lilac satellites were designed and built by students at HIT.
Students? You mean people in their 20s? That is amazing. For our beginners, nano means very, very small, but even though they are small, they are very mighty.
Mighty, M-I-G-H-T-Y. It means strong and powerful. These student-made satellites have been launched into space to study the atmosphere and even to take pictures of the moon.
I'm looking at a model of the Lilac 2 right now. It looks like a beautiful piece of jewelry. It has tiny cameras and sensors. Sharon, what is a sensor?
A sensor is like a mechanical eye or ear. It feels things. It can feel the temperature, the radiation, or the magnetic field of the Earth.
HIT students are famous for this. They don't just read books, they build real things. There's a saying at HIT, seeking excellence, practicing through hard work.
That is the spirit of this university. They're not afraid to fail. Building a satellite is very difficult. If one tiny wire is wrong, the whole mission might fail. There's no way to go into space and fix it with a screwdriver.
True, you can't call a repairman in orbit. This is why they have to test the satellites in special rooms here at HIT. They have a vacuum chamber to simulate the cold of space and a vibration table to simulate the shaking of the rocket.
Simulate, S-I-M-U-L-A-T-E. To our listeners, this means to copy or pretend. They pretend it is space to see if the satellite will break.
I see a satellite here that looks like a big umbrella. What is that?
That is a communications satellite. The umbrella is actually a giant antenna. It catches signals from the Earth and bounces them back. Without these, we couldn't watch live sports from the other side of the world or use the internet.
So, satellites are like our eyes and ears in the sky. They help us stay connected. And knowing that students just like our listeners are building them makes it feel much closer to us.
Exactly. Space is not just for old scientists in white coats. It's for young people with big ideas.
Sharon, I am standing in front of a very strange object. It looks like a giant burnt metal bell. It is black and brown, and it looks like it has been in a fire. What is this?
That, Mark, is the most exciting thing in the museum. It is a real return capsule from a Shenzhou mission.
Capsule. C-A-P-S-U-L-E. For our beginners, think of a small, strong room. This is where the astronauts sit when they come back to Earth.
Why does it look burnt? Did something go wrong?
Actually, no. It looks burnt because it is success. When the capsule falls back to Earth, it travels so fast that it rubs against the air. This creates a lot of friction.
Friction. F-R-I-C-T-I-O-N. If you rub your hands together very fast, they get hot, right? Now imagine rubbing against the air at 20,000 kilometers per hour.
The temperature outside the capsule reaches 2,000 degrees Celsius. That is hot enough to melt steel. But inside, the astronauts are safe and cool.
That is because of the heat shield. HIT scientists are world leaders in thermal protection. They developed materials that can burn away slowly to take the heat away from the capsule.
I'm looking inside the capsule now through a small window. It looks very crowded. There are 3 seats, many buttons, and screens.
It is very compact. COMPACT. This means everything is packed tightly together. In space, every centimeter of space is very expensive.
I see a spacesuit next to the capsule. It looks like a heavy white balloon. It has a big gold helmet.
That is the Feitian spacesuit. It is like a personal spaceship for one person. It has its own air, its own heater, and even a way to drink water through a straw.
Astronauts wear this when they do a spacewalk. In English, we call this an EVA, extravehicular activity.
Extra means outside. Vehicular means the spaceship, so activity outside the spaceship.
Imagine floating in the black silence of space, looking down at the blue Earth. It must be the most beautiful feeling in the world.
But it is also dangerous. There is no air to breathe, and there are tiny rocks called micrometeoroids flying around. The suit must be very strong. HIT helped design the mechanical arms that help astronauts move around outside the space station.
The mechanical arm, I saw it on TV. It looks like a giant robot arm that can move very heavy things. It's like a giant helping hand.
HIT is very proud of that arm. It is one of the most advanced robot arms in the world. It can even walk on the outside of the space station like an inchworm.
An inchworm? That's a funny image, a giant robot worm in space.
But it shows how smart the technology is. We also have exhibits here about how astronauts eat. Do they eat normal food?
They have special food. It's often dried or in vacuum packs. They have kung pao chicken in space. But they have to be careful. They can't eat bread because the crumbs would float away and get into the machines.
Crumbs. CRUMBS. Tiny pieces of bread. In space, everything floats. This is called weightlessness or zero-G.
Weightlessness sounds like a superpower. You can fly like Superman, but it's actually hard for the body. Your muscles get weak because they don't have to work. That's why astronauts have to go to the gym every day on a treadmill.
Even in space, you have to go to the gym. No excuses.
We have reached the final part of our tour. We are looking at a group of robots with wheels. They look like high-tech golden spiders.
These are the Rovers, ROVERS. A rover is a robot that can drive on the surface of another world, like the Moon or Mars.
This one here is U2, the Jade Rabbit. It is a model of the one that is currently on the Moon.
Look at the wheels, Mark. They aren't made of rubber like a car tire. They're made of a metal mesh. Why?
Because the Moon is very extreme. In the day, it is 120 degrees Celsius. At night, it is minus 180. Rubber would melt or crack. These metal wheels are designed by HIT.
HIT again. They really are everywhere in space. The professor who designed these wheels, Professor Deng Zhongquan, is a hero at this university.
I can see why. The Moon is covered in regolith, which is very fine, sharp dust. It's like driving on a mix of flour and broken glass. Normal wheels would get stuck, but these HIT wheels can climb over rocks and through deep dust.
And look over there. That is the Zhurong Mars rover. It is bigger than the Moon rover. It has 6 wheels and looks like it has eyes.
Those eyes are cameras that take 3D pictures. Mars is much further away than the Moon. It takes 20 minutes for a signal to go from Earth to Mars.
So the rover must be autonomous. AUTONOMUS. For our beginners, this means it can think for itself. It can see a rock and decide to go around it without waiting for a human to tell it what to do.
That is very high-level AI. HIT also helped with the landing of the Mars rover. Landing on Mars is called 7 minutes of terror because it is so difficult.
Terror. TERROR. Extreme fear. If the parachute doesn't open at exactly the right time, the rover will crash and break into pieces.
But it didn't crash. It landed perfectly, and now it is studying the red soil of Mars to see if there was ever water or life there.
It makes me wonder, what is next? I see models of lunar bases here. They look like little bubbles on the moon where people could live.
That is the future. Scientists want to build a moon village. They might use 3D printers to turn the moon dust into bricks for houses.
3D printing a house on the moon? That sounds like a movie.
But at HIT, movies become reality. The students here are studying how to grow plants on the moon and how to get oxygen from rocks.
This is why we say space exploration is for the whole of humanity. It brings us together to solve the biggest problems.
Mark, we have seen so much today. The giant rockets, the tiny student satellites, the burnt return capsules, and the brave rovers.
It makes me feel very small, but also very proud. We are part of a species that can leave its home and touch the stars.
And for our English learners, remember, every astronaut started with one small step. Every English speaker started with one small word.
Just like the HIT motto says, seek excellence. Don't be afraid of the vacuum of not knowing. Keep learning and you will reach your own stars.
What a wonderful way to finish. Sharon, I think I need to go and buy a model rocket now.
Me too. Let's head to the gift shop.
Thank you everyone for listening to this very long, very special episode of Special English Corner.
We hope you enjoyed our tour of the HIT Astronautics Museum.
Keep practicing, stay curious, and keep looking up.
Goodbye, everyone.
Bye-bye.